Welcome to Kotlin Multiplatform Alchemy, making gold out of your Swift Interop. My name is Pamela Hill. I'm a developer advocate at JetBrains. Thank you. So this talk is a deep dive for folks with mixed code bases about improving their Kotlin Swift Interop both now and in the future. And just a warning, we're going to get really deep in the weeds. My talk has three key takeaways. Firstly, what is the current state of Kotlin Swift Interop? Which Kotlin features can I use from Swift with confidence, and which Kotlin features should I rather avoid? Secondly, there are already techniques that you can use to start making your Kotlin Swift Interop better. And we'll be looking at 8 little nuggets of interop tricks that you can start using today. And thirdly, a much anticipated Swift export is what JetBrains is working on at the moment, which will alleviate some of the Kotlin Swift Interop challenges in the future. So we'll be looking at its goals and what kinds of problems it aims to solve. We'll also be looking at the design process of a specific feature as an example. It's going to be a super dense, but not too long session, so let's get started. I want to clarify what I mean with Kotlin Swift Interop. I'm going to use this term whenever I'm referring to calling Kotlin declarations from Swift. Interop issues don't actually affect the internals of a declaration, but rather just the calling of that declaration. So perhaps you're wondering, what exactly is the problem with Swift? Well, not with Swift, but with Kotlin and Swift. So a decision was made around 2018 for Kotlin to be interoperable with Objective-C, not Swift. Why? Well, it's so that Kotlin can be used in all iOS projects, not just the Swifty ones. And because Swift was still on the road to maturity and adoption at that stage, there were still a lot of Objective-C projects out there. And this means that Kotlin is not directly interoperable with Swift, but rather indirectly through this Objective-C bridge. And this has the following implications for Swift developers. So some Kotlin features work exactly as expected. Some work with a teeny tiny workaround, some work better with a community solution, and some unfortunately don't work optimally right now or don't work, but those are in the vast minority. And this takes me nicely into my first section about the current state of Kotlin Swift Interop. So in this section, we're really going to zoom through all the Kotlin features into which interop categories they actually belong. And I'm going to share some observations on how support for features are spread. But I'd like to begin with a spoiler. I'm all for the spoilers. The good news is that what works far outweighs what doesn't work or isn't supported. So let's look at what works as expected. So here I'm going to zoom through just a few of the main features, classes and functions, properties, and so on. Then what works with a teeny tiny small workaround, by far the biggest category. And here we have things like top-level properties and top-level functions, exceptions, and so on. And what works better with a community solution library. Just two features here related to asynchronous programming, so suspend functions and flows. What doesn't work optimally right now are things like data classes, and generic functions, and so on. And lastly, what doesn't work and shouldn't be used? Things like functions with var args or value class parameters or inline functions. So that was a lot of detail to take in. And it's actually not important for you to have memorized everything because it actually is quite well documented. And I'll show you exactly where. I'd like to make an observation to you about what we just saw. My first observation is really that the more common features tend to be better supported. Here I'm thinking of things like classes and functions and properties over something like a reified function. Following on from this, we can see that the simpler way of doing things, or choosing simpler features, is usually the best approach with the current state of Kotlin Swift Interop. We could also see that the first three categories, or what is supported, has far more features in it than the latter two categories, which is not so well supported. So to reiterate, what works far outweighs what doesn't work, or at least visually. Look how much green there is. Look how much actually works. It's actually quite a impactful visual, just to see that there's a lot of features that are supported in some way or another. So I mentioned that this is well documented, and you can find it here at the Kotlin Swift Interpedia. So if you take one screenshot today, this is your chance. So the Kotlin Swift Interpedia is the interoperability encyclopedia, and it explains how Kotlin features can be used from Swift. And there are lots of code samples, and it explains your workarounds and your community solutions very thoroughly. It also gives a playground app where you can sort of fiddle with the code to see how you can get all those interop tricks to work. And of course, our new Polyglot IDE fleet also supports navigating from Swift to Kotlin and back again. Here we can see that if I'm in a Swift file and I want to see the implementation of a top-level Kotlin function in my shared code, I can just command-click into it, and I'm taken to the Kotlin function, the implementation of that function. So we can also go back into the opposite direction and get the usages of that Kotlin function. With Fleet, we have things like cross-language renaming, refactoring, and debugging as well. So next, let's look at the current techniques to improve your Kotlin Swift interop that you can use right away. First, I want to show you how you can go from your Objective-C header that the compiler generates, that the Kotlin compiler generates, to the Swift interface that you can examine for interoperability issues. And that's basically with 2 and maybe a quarter or a half, depends on how you count. So we've got Xcode, that's one tool. Then there's a command line utility called SourceKitten. And hopefully our IDE Fleet will complete the third one and support this functionality soon as well. So I'm not going to go into the details of how to do this, because it is, once again, well documented. And I also have a research article on my blog that shows you the links to where it's well documented. I'll share the link again at the end of the presentation. But if we want to go from Kotlin to Objective-C to Swift, we can see that we have this Kotlin function. It's a top-level function that converts a Celsius temperature into a Fahrenheit temperature. And then the Kotlin compiler will generate this rather very complex-looking Objective-C header for it. And then if I use Xcode or SourceKitten to generate my Swift interface from this Objective-C header, I get this as a result. You can see that it's Swift code, and it has got a wrapping Celsius to Fahrenheit KT class because it's a top-level function. And you can also see that the function is a class function. And that's very similar to static functions in Kotlin. So you don't need an instance of the wrapper class in order to call the function. Let's look at those 8 little nuggets of interop gold. I know that's partly why you're here and partly because of the Swift export, but let's get into those little nuggets next. So there are 4 API solutions that have been created to improve our Swift API, Swift APIs. And those are Object-C name, should refine in Swift, hidden from Object-C, and KDoc. So the first 3 are annotations, and then, of course, KDoc is just comments. And then there are feature solutions like exceptions and errors, typed interfaces, coroutines, and flows that are related to, obviously, more specific features. So our first feature allows us to rename the Swift version of a Kotlin declaration, leaving that Kotlin declaration name unchanged. So let's look at an example. So here that we have in our Kotlin file, we have two country.kt files. One is in a database package and the other is in a network package. But when Kotlin is mapped to Swift, both country classes now appear in the same module. With the one is called country and the other one is called country underscore to differentiate between them, which is which. To solve this, we can go back into our Kotlin files and see and add an annotation to the database country class called at object C name, and we can give it a Swift name of database country. And when we go back to our Swift code, we can see the one class is called database country and the other one is simply country, that is our network country. Our next API feature indicates to the Kotlin compiler that the Kotlin version of a particular function is not ideal for use from Swift, and we want to refine it in Swift itself. So we can, as an example, we're going to use some ranges from Kotlin and Swift. So in Kotlin, ranges can be represented as, for example, 0.5 or 0.less than 5 for exclusive ranges. And in Swift, similarly, 0.5, just be different, and 0.less than 5. So say that we have a function called has number of capitals inside our country class. And that function can be used to determine if a country has a number of capitals in a particular range, say 2 to 3. Now, you might say, Pamela, that is a weird function to write. And that is because there are actually countries with 0 capitals, Antarctica, up to 3 capitals, South Africa. Then that's probably why I know, right? So we can see here that in Kotlin, we can provide that range in an idiomatic way. We can say 2.3. But in Swift, our end range parameter has become a Kotlin end range parameter. And so that can't be called in a very idiomatic way in Swift. So instead of our Swift range shorthand that we're kind of used to, the 2.3, we now have a constructor call. And that's just not very nice. So instead, let's use should refine in Swift the annotation to indicate that we want to refine the function in a better way in Swift. We simply annotate the function with @should refine in Swift in our Kotlin code, and then in Swift we have to create an extension on the country class that has a function called has number of capitals that takes a closed range, a Swift closed range parameter. Inside this function, we're actually using the Kotlin function that we originally had that has been rewritten as __ has number of capitals. And this __ mechanism means that it's not available for auto-completion in Xcode. So now, if we look at the calling Swift again, we can see that we can use the idiomatic Swift ranges instead. We have refined it nicely. Our next API solution is @hidden from object C. Now, this annotation indicates that the Kotlin declaration shouldn't be exported to the Objective-C header, and so on, and therefore it won't be available in Swift. It's for Kotlin only. It's for Kotlin buddies only. So we can have a similar effect in the Kotlin with the Kotlin internal modifier, but this will also affect the visibility of the Kotlin declaration to other Kotlin modules. So why would we want to do this? Well, it will affect our API surface for sure, but it also will reduce dramatically, hopefully, our app's binary sizes. Next, we want to look at documentation. So documentation is super essential to understanding the basics as well as the finer details of any API. And so providing documentation for your shared Kotlin API will allow you to communicate with its users on matters of usage and do's and don'ts and so on. And you can use KDoc and provide this kind of documentation to your API users, and your comments, they can see your comments in their IDE. So whether it's Xcode or Android Studio or Feed. So you have to opt in to KDoc comment export in your Gradle build file, and note that not all comment types are exported, but there are many that are. Things like @param, for example, don't work, but just creating a normal comment or having a return does work. So let's have a quick summary of those first 4 nuggets. So we had object CNAME, where we renamed the Kotlin declarations in Swift. Then we had should refine in Swift, where we defined the Kotlin function a bit better in Swift. And then we had hidden from Object-C, so we didn't export the declaration to Objective-C in Kotlin and Swift. And we had KDoc for documenting our shared Kotlin API a little bit better. So the first feature solution that I want to show you is errors and exceptions. Now this is a little bit of a strange dialogue, because in Kotlin, exceptions are not checked. So exceptions need to be handled gracefully. For example, if I have an app that calls a web service, and that web service call has a timeout, I want it to be handled nicely. I don't want it to cause the app to crash. So instead, but note that exceptions aren't checked by default in Kotlin. Why? Well, firstly, we learned from the likes of Java that there was going to be a lot of boilerplate, but also folks were going to catch the exception and not do anything with it. They would sort of say catch exception and then empty braces. So errors should also not be caught. Here you can think of things like out-of-memory error from the JVM, indicating that the app has run out of memory space, and it's something that you actually can't recover from. But in Swift, the 2 concepts are switched. Errors should be checked, and exceptions should cause a crash. Weird. So let's say, for example, we have a suspending function called getCountries that lists that gets a list of countries from a web service. So it's a suspending function. And when we examine the Swift interface, we can see that only cancellation exceptions are converted to errors, and uncaught Kotlin exceptions are going to be fatal. Eek! How are we going to fix this? Well, we must list all our exceptions in the function's @throws annotation. So, for example, here we're adding a countries unavailable exception to the @throws annotation of our getCountries function. So any class or any function or calling code will know that it must gracefully handle this exception, as it is likely to occur. So when we look at our Swift interface, we can see that only countries unavailable exception will be converted to errors, which will then be caught. This is much more aligned with what we'd like. Our next feature solution has to do with typed interfaces, or interfaces with a type argument. So interface of something with type T. So let's look at what the problem is here. So in Kotlin, we have typed interfaces, something with a type argument. And in Objective-C, these types are mapped to protocols, but there is no type argument support on these kinds of data structures. So in Swift, the protocols, Swift protocols, do have type arguments, but because of this Objective-C bridge, this type argument has now become optional any. So this is not ideal for our Kotlin, because our Kotlin type argument is lost, and we lose all our type safety. So let's have a look at an example. Here we have an interface called cache that stores something of type T. We can get the cache value, and we can set the value in the cache. Unfortunately, due to that pesky Objective-C bridge, the type argument will be lost, and so in Swift, the type of the cache will be almost always optional any, and we'll have to do typecasting in most circumstances. So the trick to resolve this is, instead of a typed interface, is to use an abstract generic class. And this way the type argument is going to be preserved. So instead of our interface cache, we're going to have an abstract class cache. And that will preserve our type argument for us. So we can see here it's preserved, and we can also go ahead and extend from this class in Swift. Next, let's have a look at suspend functions, so asynchronous programming concepts. So unfortunately, Objective-C doesn't have suspend functions. So they are represented in Objective-C as functions with callbacks. From Swift, we can use the async await mechanism as well. So that's a slight mitigating factor. It does read a little bit better. However, whether you use functions with callbacks or the async await mechanism, cancellation is not supported out of the box. So this is a problem, as potentially long-running operations will continue meandering until the suspend function either times out or completes, which can be a huge waste of resources. Let's look at an example. Here we have a suspend function that gets the weather at a particular location. Maybe we're a little weather station. And when calling this function from Swift, we surround this function call with a task to support concurrency. But when we ask it to cancel, the work of that suspend function doesn't actually cancel or stop. So instead, we're going to use a very nice library from Rick Clefas called KMP native coroutines to help us. We have to mark our Kotlin function with @native coroutines, annotation, and then we wrap that suspend function call in Swift with async function. And when we call cancel on the asynchronous programming supporting task, that work will be cancelled from within the suspend function. So KMP native coroutines provides that cancellation support that we need. But we have to remember that at the moment, Kotlin Native requires us to call suspend functions on the main thread. Now, this won't be a requirement for all that much longer. I think it will be from Kotlin version 2.0.20. That won't be a requirement any longer. There is also another community library called Sky from TouchLab that similarly supports calling suspend functions and supports the cancellation that we need. You don't actually have to change any of your code, you just include it in your Gradle build file. The next logical sort of step to look at here is flows, which gives you a stream of values asynchronously. So let's look what the problem is here. Let's set the scene. So Kotlin's flow is represented as an interface. And in Objective-C, interfaces become protocols which don't support value types. So in Swift, those flows are going to lose the generic types. So similarly to suspend functions, we also need that cancellation support and main thread safety. So let's look at a similar example to what we had in a suspend function section, but instead of returning just one weather object, we're going to return a flow of weather objects. To solve this problem, we can use Sky. Sky will convert the flow into a custom subclass of Swift's async sequence. And using Sky, we've got our type value that's preserved, the cancellation that's supported, and the main thread safety is still guaranteed automatically for us. So here, when we call the getWeather function to get that flow, we just iterate over the weather objects using for await in. KMP native coroutines also supports flows using that annotation and a wrapper function called async sequence that we saw, similar to what we saw in the suspend function section. So let's just summarize the features once again. So we had throws where we had to list our exceptions in order for them to be caught properly. We had abstract classes that we can use instead of typed interfaces to retain our type argument. And we can use libraries like KMP native coroutines and Sky in order to correctly support and call our suspend functions and flows. And finally, let's really talk about the JetBrains Swift export project that we hope will alleviate all the major pain points and even the minor bugbears related to Swift Interop in the future. The goal of this project is to deliver a more pleasant experience for developers out of the box when using Kotlin from their Swift app. So more specifically, we want to address the following problems. There is we know that the generated Objective-C API is considered unaesthetic and legacy by iOS developers. And we want to fix that. We want to make it more in line what iOS developers know and love about using Swift. We want to support more language features, and we want to have better integration of the compiler with other parts of the developer experience, like the IDE, tooling, and libraries, and so on. And this is, of course, not an easy task. Swift and Kotlin might look superficially similar, but believe me, the design teams made a lot of different decisions. So we're going to look at an example now, and we're going to look at the design process that goes into one such feature. We'll be looking at something which the team was recently faced with, and that was how to map Kotlin modules and packages or namespaces to Swift. So let's define the problem. Kotlin has packages and modules, and packages organize declarations into trees, and so does modules, but on a larger scale. So this is in contrast with Swift that only has modules, which it uses for both purposes. So there is no one-to-one mapping between Kotlin's packages and modules and Swift's modules. We'll have to invent something. We'll have to get creative. So before we go on to the Swift export problem, I just want to refresh your memory in terms of the Objective-C problem, where all the modules were mapped into a single Objective-C header file. Saying we've looked at this example before, I just want to refresh your memory. We have those two country files, the one in the one package and the one in the other package. And when it's mapped to Swift, both country classes appear in that same module, and there is some name rewriting. But we can use the Object-C annotation to rewrite the name of that Swift class. So let's look at the Swift export problem. Now, perhaps you're wondering, can't we just map Kotlin packages to modules in Swift? And the answer is, sadly, no. This is because Swift doesn't allow us to nest modules inside other modules. And because Swift doesn't allow cyclic dependencies between modules. So module A can't depend on module B and back again. So unfortunately, we're going to have to solve the problems of modules and packages separately. Let's look at modules first. So a solution here is to export one or more Kotlin modules as a Swift module. We can do that. So for example, if our project looks as follows, we have a feature module A and a feature module B, and they both depend on another dependency called Kotlin X coroutines. So here we could export feature A, feature B, and Kotlin X coroutines separately as Swift modules. We could also go ahead and, for example, for Ktor, sort of export Ktor core and Ktor logging into one Swift module because they're commonly used together. From Swift, we can then import each one of them separately. If I don't need the API from feature B, I don't need to import it. The point here is that I don't have to export all my modules into only one module. So let's look at how we solve the namespaces part next. So removing packages was actually presenting a difficulty from a tooling and developer experience perspective. So instead, we decided to keep it to packages. We decided to keep packages. So this is going to be our running example from now on. We have a class called weather screen view model inside com.jetbrains.weatherapp. So here, if we want to create, if we want to evaluate the options of what we could possibly do, we could, as option 1, we could provide a package-like namespacing in Swift, where we actually collapse or merge the package name into the declaration name. So as you can see here, weather screen view model becomes com JetBrains weather app weather screen view model. So it's obviously a very simple solution for us to implement, but it's not so nice for you. So it makes for a terrible developer experience, and that's not what we're about. So the code is cluttered, and the code completion takes a very long time, much longer than it should. So that's not ideal, so let's move on to the next option. Our next option is to use enums to emulate that package, the package and then place the declaration of the class inside the enum. This gives a better namespace experience, similar to what we have in Kotlin, but it doesn't work well in a multi-module export, where you could have the same package but in different modules, which is common in a large app. Declarations are also hard to read, as you kind of have to follow along with the tabs, and with many tabs, it becomes hard to read the class definition. So instead, we went for this option where we share the enum structure between all the Swift modules. We share it. And then we define an extension on the package and the package enum with our class inside of it. This way, there is only one tab that we have to add the class definition in. But this is, unfortunately, a lot more difficult for us to implement, but that is the option that we've chosen thus far. We've also made a further refinement to use type aliases to nested declarations, so that the declarations look so much nicer. So we also know that, of course, we could have namespace clashes. So in that case, we could decide to either do something like not producing the type alias or using underscores to differentiate between them. So not everything is going to be sunshine and daisies with Swift export. We will improve what is possible to improve. Those two languages are very different languages. So if you want to chat more about Swift export, there is a very exciting demo. Come to our booth and have a look at the demo that Sergey Bologopov is going to show us. He's going to implement a particular feature in Swift export and show you how the project works. So in summary, we're almost at the end of the talk, and I want to congratulate you. This was a very dense talk and a lot of detail, so well done on making it all the way through this talk. Our first key takeaway was that what the current state of Kotlin Swift Interop was. And visually, just look at all the green. There's a lot that works. But using Kotlin from your Swift app is not supposed to be an exercise in pain and futility. It's still supposed to be a lot of fun. So secondly, we looked at the techniques that you can use to make your interop better already. And thirdly, we looked at the Swift export project, its goal, and what problems it aims to solve. We also looked at an example to see what the design process looks like for supporting one such feature in Swift export. I hope you enjoyed the talk. And thank you for your attention. Have a great KotlinConf, and don't forget to vote.